Grade 10s, here we go. Continue with the trig work that we've been doing. Big change with trig. Two main calculations. Because trig deals with right-angled triangles, what we talked about was we did some Pythagoras review, calculating side length. We reviewed the idea of the 180 rule, I call it, that all the angles in a triangle total 180 degrees. This is review from previous math courses. Finding side lengths with Pythagoras, angle sizes using the 180 rule. But these only work. I can only find side lengths using Pythagoras using side lengths. I can only find angle sizes using other angles. And that's the big difference now as we move into the trig stuff. Is we're going to look at the sine, the cosine, and the tangent ratio. And what trigonometry now starts to do is it calculates side lengths and angle measures in triangles, but we're going to work with the two together. We're going to work with angles and sides together now instead of individually. So we're going to continue with right triangles. We're going to talk sine today and then cosine and tangent. This is all about setting up ratios of sides. Same processes for all three, sine, cosine, and tangent. That's what's great. But you're going to have to do some thinking to figure out which process to use. Before we go any further, one thing, degree mode. Your calculator must be in degree mode. Now, if you don't have a graphing calculator, at the top of the display on your calculator, it might have a D or an R or a G. You'll have a button on your calculator that has DRG. If you hit that DRG button, you need to make sure that your calculator has a D on the display really small, or it says DEG for degree. We don't want it to say rad for radians or grad for gradients. That's stuff that you'll look at in the future, possibly in math courses. All the time, you pull out your calculator, make sure you're in degree mode. If you have a graphing calculator, what you need to do is you need to hit the mode button on your calculator beside the second function key. When you hit mode, now that there's drawing on the page, it won't do it. When you hit mode, you notice that we have this radian or degree. You need to make sure degree is highlighted. If radians is highlighted, you need to change it. Use the cursor, highlight which one you want. Like here it's flashing on radian. If I hit enter, it's now in radians. But we don't want that. Make sure degree is highlighted, always in degree mode. Now let's get out of there. So, essential, you're always in degree mode. So let's use the calculator with the sine function. So what the trig ratios are, sine, cosine, and tangent, they're fraction or decimal values to describe the relation between certain sides of the triangle. We have to figure out which sides to use, and then the calculator becomes really important with this. Two things. First one is calculating the sine value. The second one is calculating angle measures. There will be times when we see that we have the sine of 30, or the tangent of 12, or the cosine of 47. All this tells us to do is exactly what it says. You want to hit sine 30. That's it. You then will probably get a really long decimal. Sometimes you don't, but usually you do. You want to put the 4 decimal places down. So sine 30. If I'm on my calculator, I'm simply going to hit the sine button. You see that there's a bracket. You put the degree in, sine 30, Always make sure you close the bracket when you input, and then you hit enter. Well, look at that. Sine 30 is a nice simple value. Like I said, there's a couple, but most of them will be big decimals. Sine 45, not too complicated. Sine 45, close your bracket, hit enter. 4 decimal places, decimal 7071. So on your calculator, do sine 70 and do sine 25. Sine 70, 0.9397. Sine 25, 0.4226. 4 decimal places gives us enough decimal values that our answer will be accurate. So you're going to see sometimes when we do calculations, it'll say sine of a particular angle. Now, based on what we've talked about, anyone know what angle that would be? Well, if you think about it, remember last lesson we talked about the importance of the reference angle. All questions start with the reference angle, so these angles all represent the angle that's being used in that question. So we're starting to put things together a little bit. Now, the second way we use the calculator is if we don't have the angle given to us. In this case, theta is a way to write the angle because up here we had the angle and we just signed it. Well, there's going to be situations where we have to calculate an angle. And when we calculate an angle, and we'll stress this over and over, but we want to hit second function and then sine. This is essential to finding an angle measure. It's not just sine, but second function sine. It's what gets referred to as inversing trig. We want to inverse sine to figure out the angle size. That's what we're looking at doing. You will see that when you hit inverse sine, you'll know you're in the right situation because it's going to give you that on your display if you have the graphing calculator. That little -1 says we are inversing sine. And then we're going to put a decimal or fraction value. So let's try the first one. We want the sine of decimal 5638. So on my calculator, because we don't know theta, the angle, we're finding the angle. Second function, sine. There's our sine with the little -1. Our decimal is 0.5638. We can punch that in, close the bracket, and hit enter. And there, we should get a value that represents the angle size. Now, depends, some questions differ, but angles, usually to the whole nearest degree is acceptable. 34.3, the 3 tells us to stay the same, so we have an angle that's 34 degrees. So sine theta is equal to decimal 5638. Well, that tells us that theta angle is 34 degrees. So try B, same thing. Sine theta, decimal 1487. Want to find the angle, so we have to second inverse sine. And the decimal there is 0.1487. Close the bracket, hit enter, and how big is our angle in that case? Well, to the nearest whole angle, 5 tells us to round the 8 up to 9. So in that case, our theta value is 9 degrees. That's what we're doing to calculate angle size. Now, you're going to see that we don't always have decimals. We're actually normally going to have it in fraction form Because, like I said a couple minutes ago, sine, cosine, and tangent are always ratios of sides, and a ratio gets put into fraction form. So there's two things you could do here. Depends upon the calculator and how competent you are. Well, one possibility is we could actually first turn the 7 divided by 11 into a decimal. So convert a fraction to decimal form. So 7 divided by 11, just do the division of it, to 4 decimal places. Decimal 6363. So sine theta decimal 6363, it's the exact same thing, it's the decimal version of the fraction. So now we can calculate theta, and because we're calculating the angle, we need to second sign decimal 6363. So on our calculator, second function sine, because we're finding the angle. You're going to hear me repeat that over and over and over because it's essential. You have to remember the second function. So second function, 0 decimal 6363, close the bracket, and what do we get? 39.5 is a 40-degree angle. Now, while I have my calculator out, it is possible to work with the fraction form. I want second sine, but instead of putting the decimal in, we actually want second sine, and I'm just going to write it here first. We don't want the decimal, we actually want to put the fraction form in. Well, it'll give me the same thing that I could just put the fraction as division. 7 divided by 11. I could put that inside the brackets. Now we just calculated 7 divided by 11 is 0 decimal 6363. So if I do the inverse sine of the fraction, should be the same thing because it's just different forms of the same thing. Now in this case, it's off a little bit different as we get to the lower decimals, but that's because 7 divided by 11 isn't ended after 4 decimal places. But if I round, I still have a 40-degree angle. So two things to do when it's a fraction form. You can turn it to a decimal, or you can work with it as the fraction. So in this case, either way we did it, theta was 40 degrees. So give D a try. Sine theta 62 divided by 66. We want to find the angle, try it as a decimal, and try it as the fraction. See what you get. So in this case, it was sine theta 62 over 66, trying to find the angle. Well, the first possibility is 62 divided by 66. Well, this could be exactly the same as sine theta as the decimal. 0 decimal 9393 and so on. Well, in that case, I could now calculate theta using the fraction or the decimal. Should give us the same answer because they're the same thing, because the decimal is the same as the fraction. So, want to find the angle, second function sine 62 divided by 66 gives me the fraction form. Hit enter. We have a 69.9 or a 70-degree angle. Well, what happens if I second sign the decimal? We said the decimal was decimal 9393. Close the bracket. Again, the decimal values, the further you go, are off a bit, but we're getting the same angle. Either situation gives us 69.9 or a 70-degree angle. So theta here is 70 degrees. Using the calculator, This calculating angles, we're actually going to use next lesson more, but it's important you understand. Today, we're going to use this idea of when it tells you you have the sine of the angle, we just push sine followed by the degree measure. So let's take a look at how this whole trig thing works. Now, like I said a couple times now, these trig ratios, whether it's sine, cosine, or tan, are just comparison of sides. Each trig ratio compares different sides though. Today we're doing sine, and we're looking, sine is always comparing the opposite to the hypotenuse. So last day we looked at every triangle can have sides labeled opposite, hypotenuse, and adjacent. But what did we need first? We need the reference angle. We need to figure out which angle to work with so we can label the sides. And now we're going to start working with the trig ratio. All these little bits and pieces we've done are going to start coming together, hopefully. So let's take a look at the example. Here we go. We have a triangle. We see that it's a right triangle, which it has to be. So we want to solve for side x here. Well, to solve for a side in a triangle, we need to go through several steps, but they're not overly complicated, and we've done a bunch of them. Step number one, I've said it a couple times today and a whole bunch the other day, we need the reference angle. We have to choose one of the angles. We have angle 1, angle 2, and angle 3. Hopefully you're sitting there saying it can't be angle 2 because we never use the 90 degree as our reference angle we talked about last day. So if I'm trying to find x, angle 1 or angle 3, which angle should I use? Well, in order to find something I don't know, I have to use information that I do know. So our reference angle has to be known. We're going to have to work with angle 12 degrees in this question because our reference angle must be known. We have to use what we know to find what we don't know. So there's your first step. We're going to work with the 12 degrees. Second step from yesterday, we can now label our sides. Well, when we label our sides, across from the 12, across or opposite the reference angle is side opposite. Opposite the hypotenuse is always, opposite the 90 degrees is always the hypotenuse. That leaves the adjacent. So we look at this, we have 3 sides, but our trig ratio, sine, only uses opposite and hypotenuse. So why is that important to understand that sine is opposite over hypotenuse? Well, in this case, when I use the 12, we want to know the opposite side x, so that's important. And we want to use the hypotenuse because we know it. The adjacent side in this question, we don't know it, and the question doesn't ask for it. It's kind of a useless side in this question. That's why sine is going to be helpful here. We're finding the opposite side using the hypotenuse because we know it. So now we substitute the appropriate information into the sine function. Sine is opposite over hypotenuse. Theta is our reference angle. So we always want to start. Sine theta is opposite over hypotenuse. What can I substitute in? Well, we know which angle we're using. We're using the 12 degree angle. So we know that the sine of 12 equals the side opposite over the hypotenuse. Well, side opposite is the x. The hypotenuse is 34. So there's the sine ratio with the appropriate information substituted in. Sine of your reference angle equals opposite over hypotenuse. And now to solve, you know what? We've got a proportion again. I can put sine 12 over 1. Now I have a proportion I can cross multiply. That's our last step every time. When I go to cross multiply what you can. Now we have to be careful because I get all kinds of students that say, oh, it's 12 times 34, and that's not it. This isn't up top here just a 12. It's sine 12. When we substitute into our calculator, we have to make sure we're inputting sine 12 times 34 divided by that 1. And that will give us our x. And x represents the opposite side, which is the unknown. Make sure you're inputting sine times 12. So we go to our calculator. We want to input sine 12 degrees. Make sure you close that bracket. Times 34. There's our first calculation in the cross multiplying. And then we divide by 1. What does dividing by 1 do? Nothing. So what's the length of our side? Sides can go to 1 decimal place. Beside the 0 is a 6. 6 tells us to round up. So we end up with a side length of 7 1/10. X is 7.1 meters. There's, got a lot of circles up there. There's what X works out to be, 7.1 meters. Why do I like 7.1 meters as an answer? It's smaller than the hypotenuse. Hypotenuse has to be the longest side, so our 7.1 makes sense. Now, I just want to show you, going back to the calculator, a common error over and over is students will go sine 12, they won't put the bracket in, and then they'll multiply by 34 and hit enter. Totally different value. Oh, I got to divide by 1. Totally different value here. The reason being, here we're getting the sine of just the 12. If we don't put the second bracket in, we're getting the sine of 12 times 34, which isn't a 12. You need that bracket to get sine of 12 times the 34. Little things with the calculator you have to be careful of, and that all comes with practice. Let's take a look at X on the left here, 16 and 35 degrees. Let's walk through the process. Step 1, reference angle. Which angle are we going to use? Well, we need to use the angle that we know. We know the 90, but 90 is never your reference angle. So we want sine of 35. So we're going to use the 35 in this case. Now, second thing, label the sides. Opposite, the reference angle is side opposite. Opposite, the 90, is the hypotenuse. Leaves us with the adjacent. But in this case, we're finding the hypotenuse. We have the opposite, which is good because sine of theta is opposite over hypotenuse. Trying to find the hypotenuse, we're going to use the opposite. Adjacent doesn't help us in this case. So now we can substitute in. Sine of our reference angle, don't forget to put that in, equals opposite 16 over hypotenuse, which is x. So step 1, reference. Step 2, label. Step 3, substitute into the ratio. And now the last step is we cross multiply to find a side. Set sine 35 over 1 and cross multiply. Have to be careful. This time our cross multiplying is a little different. This time we're going to go 1 times 16 and divide that by the sine 35 degrees to get x. Little bit different cross multiplying, but still a cross multiplying process. So let's go to our calculator. 1 times 16, well, that's 16. That's a no-brainer. But now we divide, and we don't divide by 35. We divide by sine 35. Close your bracket. So our 16 will divide by sine 35, and that gives us a 27.89 or 27.9 side length. X works out to be 27.9 centimeters. And again, I like 27.9 for x because it's our hypotenuse, which is longer than the 16, which it should be. There's the process for finding side lengths using sine. Stop the video, try the last one, and then we'll do it together. All right, here we go. We've got the steps here still. Hopefully you followed those. First thing, reference angle. Well, to find a side, we need to use the angle we know, which is 72. Now we label our sides. Across from the reference angle, or opposite it, is side opposite. Opposite the 90 is the hypotenuse. So again, our adjacent is this side here, but we don't know it. We don't want it in this question. So we're going to use the opposite and hypotenuse, which works because that works with our sine ratio. Make sure you plug everything in. Sine 72 equals opposite 92 over hypotenuse x. And what's great? Set it over 1 and we cross multiply. 1 times 92, and now we're dividing by sine 72 in this question. Excuse me. So we can go to our calculator. 1 times 92, which is 92, and we divide that. Excuse me, sorry about that. Divide that by sine of 72. Close your bracket after your angle, and what do we get? We get a side length of 96.73, so the 7 just stays the same, 96.7. So our x is 96.7 meters. And again, does that make sense? I like that answer because it's the longest side, which it should be because that's the hypotenuse. These 4 steps are going to become repetition. You should get sick and tired of thinking about them, but that's what helps you. Always identify the reference angle. Label the sides, opposite, hypotenuse, adjacent. Substitute into the ratio. Sine theta is opposite over hypotenuse. And we're always, to find a side length, always cross multiplying to find it. So that's our last step, to find a side length. So there's your introduction to trig. What you need to complete is pages 14 and 15 in the booklet. Not a ton of pages, but it's going to get repetitious, so hopefully a little bit of practice on this one. Still got lots of steps to learn with the other ones, which are very much the same. So get that done, and then next lesson we'll do the exact same process almost to find angle sizes. Practice, you'll get better. Have fun.